Hello, and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. This session has been pre-recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce KYZEN's own Chuck Sexton.
Hello, everyone, and thank you for tuning into my Tech to Tech presentation, which is on how to clean and protect your parts with one chemistry. And by this, we mean one chemistry that contains both the cleaning products and also the corrosion inhibitor. So you're cleaning and protecting with one product. A few basics on corrosion before we get into the actual cleaning chemistry and process. For the sake of time, I will be using most of the time the term RP, which stands for rust preventative, to refer to chemical products which provide corrosion protection. Corrosion appears in a variety of different forms. The part you see here, the steel part, has been subject to general surface corrosion, and it's oxidation of the iron in the steel. There's also pitting and galvanic corrosion and 6 or 8 others, but these are sort of the main corrosion problems that we face. The types of corrosion protection, when we sit down with a customer in an application, we always ask, how long do you need to protect the parts? And usually it's like 30, 60, or 90 days or even longer. And are the parts being placed on a ship and being sent to Asia somewhere? Do you want an oil film or a dry film? What are the different metals that you're trying to protect? And how are you packaging? How are you handling the parts before you put them in a crate or a box and send them out? Metal oxide, general corrosion can occur in a variety of different metals. This is top left is brass parts, and they've been subject to pitting corrosion. The top right is a cast steel part. Again, oxidation of the basic metal components of the metal part. Corrosion can appear a variety of different ways, even on the same part. Steel, for example, can appear brown, black, red, can even appear white. What you see on the left is an aluminum part that's corroded. The reason I show this slide is because while it's really obvious in the slide on the right, and the one on the left, it's not terribly obvious. And we always get the question, is that contaminant that we're not removing from our parts, or is that actually oxidation of the part itself? And we have means to tell that. Here's a really good example of a drive shaft that are running through a big coating line, and in between the wash and dry stages of the coating line and then the coating stage, it's about 30 minutes, and they're hanging from an overhead monorail. And this is a problem that was encountered that kind of got us to be involved in this application. Obviously, you can't coat properly over a rusted part. I mentioned galvanic corrosion. This is sort of the mystery corrosion. It sometimes takes a while to figure out. A galvanic corrosion occurs when you have parts that are in contact with each other through an electrolyte or a conductive media like an aqueous cleaning chemistry. The metals in the top left or the lower numbered metals want to give off metal ions um, quicker than the other metals you see. And here I've got zinc and stainless steel highlighted. We run into this often with aluminum or zinc die-cast parts where you have a stainless steel machine and you have a water-based medium and you're basically completing a circuit. On zinc die-cast, for example, the corrosion will appear like a white powder. How to prevent corrosion? And first and foremost, I think, is to completely remove all the soils from the parts, including oils and coolants and other contaminants like buffing compound. Apply corrosion inhibitor, and this conventionally has been done in 2 different steps, a wash step and a rinse step. And then you need to package the parts properly. So what we're doing is combining these steps. We will probably have a cleaning chemistry, what we call a combination cleaner RP chemistry in both the wash and the rinse stages. We do all of our development work and testing for our customers with the humidity chamber when it comes to evaluating corrosion protection This is the sort of the industry standard tool for evaluating corrosion protection. And we can determine very quickly whether or not particular parts will have 90 days protection or even longer in actual practice in the field. The settings are time, temperature, and humidity for one of these chambers. And just about all of the large OEM automotive customers, for example, have their own specs on the humidity chamber. I have a couple of slides here where some kind of bad assumptions were made. Coolant is normally not a good RP for steel parts. This particular company assumed that it would be, and they had a corrosion problem. We took their parts and placed them in the humidity chamber for 15 days at 90% relative humidity, 90 degrees Fahrenheit, and you can see in the top photos what happened. And then we used one of our cleaner RP combination products developed for steel in the bottom under the same conditions, and the results were much, much different. Corrosion prevention is important for brass. Here's another incorrect assumption. You know, some companies who manufacture brass parts believe that brass doesn't corrode as fast as steel, and that's generally correct, and that they can get the parts out the door and to the customer before corrosion happens. So this particular part that you see here represented 3 semi-truck loads of the same parts that were in storage in a non-air conditioned warehouse in the summertime in the Midwestern United States, and that's what happened. And so we did some work and treated these parts in a similar cleaning manner, but using one of our combination cleaner RP products developed for soft metals like brass. And these were the results under the same conditions. And you actually get much longer protection than 90 days in this particular example. I show this slide because it actually stresses my initial point that you need to clean the parts well in order to protect parts from corrosion. What you see here, the arrow points to a small spot on these parts, and through FTIR analysis, we determined that to be the coolant that was being removed. In this particular application, they let the cleaning process sort of get out of hand, if you will, and they ended up with corrosion. So we placed these parts in the humidity chamber in 10 days. You can see these black pits were under every one of those spots that you saw. And then we changed out the cleaning chemistry with again a cleaner RP combination product specific to brass, and these were the results under the same conditions. So now to get to the process side of my presentation, this is a kind of a universal diagram of a general cleaning process that I have drawn with a tank-to-tank system. This can be a conveyor washer. This could be a rotating basket washer with multiple stages, where you'll have a cleaner and corrosion inhibitor in different stages. For the sake of simplicity, I'll focus on a simple wash, rinse, dry, which is probably most of what we see in manufacturing. And we'll normally have an alkaline cleaner, for example, in the wash, and then a separate RP in the rinse. This is the way it's mostly been done in years past. Here's the problem. Once the RP in tank 2 is contaminated with the cleaning chemistry from tank 1 by carryover or drag out, no longer can we use the normal concentration measurement methods, which are conductivity, refractive index, and titration. There are others, but these are the industry standards. Once you intermix products, these generally cannot be used. And you need to know the concentration of your RP in the RP tank because that's what protects the RP that protects your parts. So we and others fought the two chemistry intermixing problem for years. And we set out to develop cleaner RP combination products, which contain both cleaner and the RP, to meet the following criteria. Basically, use the same cleaner RP product in wash and rinse stages throughout, so intermixing doesn't matter. Effectively remove difficult contaminants like chlorinated paraffinic oils and burned on carbon. Protect all the different metals, which normally are brass, aluminum, steel. Here's a slide that shows photos of parts that we protect with the combination RP product developed for steel, which also applies to copper and brass. And these are just some examples. I show that the bottom left are sintered metal or cast steel, powdered metal steel parts. These are really tough to protect, and you need a very good RP to get to 90 days in the field. Here's another example where we use this same product to clean and protect parts for a major automotive OEM, where we actually gained approval by that as an approved product by that OEM. These specs are very difficult, 100 degrees Fahrenheit and 98% relative humidity. And we needed to protect the parts in the humidity chamber for 30 days with no corrosion. We were able to do that at 3 to 5% with this product that I've been referring to that's been designed for steel. All of our cleaner RP combination products are oil splitting. I put this slide in here because this is important. The oil splitting products are much more efficient. They clean parts better and longer. The bath life on a splitter is normally 4 to 6 times what it is with the product that emulsifies the oil, which is shown here in the slides. This kind of a splitting product lends itself very nicely to coalescers, where you can remove the oil effectively. Here's a couple of photos showing what the surface of the bath looks like before turning the coalescer on, and then after turning it on. And it makes a big difference and keeps the cleaning solution, wash and rinse, very clean. In summary, the key benefits of these new combination cleaner RP chemical products are accurate concentration measurement, regardless of cross-contamination throughout the entire cleaning process. Excellent long-term protection for steel, aluminum, and brass, and in particular cast steel, which is a special challenge. Simplified process operation and effective removal of burned-on carbon and other very difficult manufacturing soils. So some frequently asked questions are in this last slide: what kind of storage are you targeting for your corrosion protection? What we target, we simulate storage inside a warehouse or inside a truck where rain's not actually raining on the parts, but you're in a very humid and hot environment. This could be the summertime in Michigan or Malaysia. Do you recommend different chemical concentrations for winter and summer? With the really difficult parts, like I mentioned before, cast steel, normally we do. With this steel product, we'll normally recommend 3 to 5% in the wintertime, and in the summer, we'll go up a couple percent to 5 to 7%, and that's in the wash and the rinse. Do these products leave a visible film on parts? They can, depending on what the concentration is that you're running and how long you need protection for. For most cast parts where you have a rough surface, you don't see the corrosion inhibitor left behind, but you will see the RP left behind on like a very shiny machine surface, a stamped part. Usually it looks like a very mild or slight white film, or can appear to be similar to water spots, if you will. Will these combination cleaner RP products pass salt spray testing? The answer is no. These are water-based RP products, and the RP will be rinsed off in a even a misting salt spray test. Salt spray is normally used for coated products, like powder coated products, for example, to test the integrity of the coating. Final question: can I clean both aluminum and steel in the same cleaner RP product? The answer is yes, and a lot of companies want to do this today. I didn't say much about the aluminum product, but we do have a very nice combination cleaner RP product for doing both steel and aluminum. And our West Coast regional manager, Scott Kane, will be giving a tech-to-tech presentation on this subject in the near future. Please tune into that one. Thank you very much for participating with me in this presentation.
Thanks, Chuck, and thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager, or you can send an email to tech@kaizen.com, and we'll have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox? Or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.